You're welcome once again to New Focused Approach to Mathematics Basic 8. This is the revised edition, and in this video, we want to learn how we can deduce the area of a circle. How we can deduce the area of a circle. Okay, so the formula that we can use to find the area of a circle, let's deduce that. We are going to use GeoGebra in doing this. Thanks to the people that worked on GeoGebra, giving us this free software that we can use to do a lot of illustration. We thank them so much for such a wonderful job. Now, with the help of GeoGebra, we can deduce the area of a circle. Now, first of all, let's have a circle, or you can have a cardboard and cut a perfect circle out of it. Locate the center of the circle and then divide the circle into number of equal parts, as many as you can. Okay, the number of equal parts. So for now, maybe let me put it to, let's say, 12 equal parts, or let me do a little bit of 24 equal parts. Now when I do that, I'm going to cut this into pieces. Remember that this is the whole circumference of the circle, right? Circumference of the circle. So the whole circumference will be of this length. Now I'm going to cut this into pieces and arrange them straight. So cut them into pieces and arrange them straight on the circumference, so that the whole of the circumference, when I arrange the pieces or the sectors, it will be exactly fit onto the circumference. Okay, now when that is done, let's take part of it. You see, there are supposed to be 12 in 22 in all. So let me take the 11 of it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the 11 is the blue one. Let me use the blue one and fit it on top of the red one. You see that after fitting on top, it will create something close to rectangle. Now I can cut one part of it into two and remove that portion and fit that into the latter part here. Or it's more or less, if I divide this into a lot of equal parts, I'll be able to get something very close to the rectangle. Okay, now we know that the distance from the point here to the point here is our radius, and then from the point here straight to this is halfway through circumference. Remember that this is a circle, okay, and then this is the circumference. So from the point, from the let me go back and then open this again. You can see that the whole length is this, but then half of it has come to this. So the whole length over here represents half. Okay, now we know that the whole length of the circle is giving us 2 pi r. We know that already. And then we are talking about halfway through that. So because the distance from here to here, which is the length of the rectangle, is half of the whole circumference. And then we know that the length from here to here also is our radius. To find the whole area over here, it just simply length times breadth, and the length is the whole of this, and then the breadth is r. So when you try to simplify this, these two can cancel this, leaving us with pi r times r will give us r squared. And so the area of a circle becomes pi r squared. This is what we know as the area of a circle, and it can be deduced from this experiment that we've conducted right now. When you have time, cut paper, locate the center, divide this, cut the paper into in the circular form, locate the center, and then divide the circle into number of equal parts that you can. Try to arrange them the way we did and put half of it on top of the other half. You see that you are going to get something close to a rectangle. And you find the area of the rectangle, you know it is pi r squared, being the length of the whole circumference, divided by 2 to be the halfway through, then times the height, which is the radius. And that gives us this formula. I'm sure this lesson has been of great help to you to understand why circle formula, area of a circle is always pi r squared. Thanks so much for watching.